All right, last example, number 4 in 10.1, and it gives us a real-world application of the sum and difference of functions. So it talks about the cost for t-shirts, and then basically the revenue for selling those t-shirts. Now, we need to come up with some code. They give us the variable, never mind. So question A wants the total cost as a function of the number of t-shirts produced. So we're going to find cost as a function of n, which is the number of t-shirts produced. And then we're also going to look at R of n, which is going to be the revenue as a function of the number of t-shirts sold. I think the revenue is a little bit easier because it tells us the t-shirts are sold for $12 each. So my revenue is going to be 12n. It's going to be 12 times the number of t-shirts that I sold. All right, for C of N, it's a little bit harder. It says that it includes $125 in fixed costs. So that's going to be there regardless of whether we make the t-shirts or not. I always encourage students to think about that as startup costs, or maybe, you know, the fuel for the printing press or electricity, or some of those costs that, you know, we have to run whether or not we're producing t-shirts. And then finally, it's $7.50 per t-shirt. So that's like materials and labor and stuff that we need to actually make t-shirts. So there, I'm going to add the 7.5N. And we have our cost function and our revenue function. Now, part B wants us to graph total cost and revenue functions on the same set of axes. And it's really important that the reason we're able to do that is we can make that assumption that we're going to sell all the t-shirts that we build, which is a heck of an assumption, but it's what we're going to roll with. So what I'm going to do, I thought they'd move together, is I'm just going to drag these down a little bit because I have the graph below. And if we look at this particular graph, we see that the cost function, which is in blue, so that's C of N, and the revenue function is in red, eventually these intersect. Now, it's important to identify what this intersection is. This intersection is when C of N is equal to R of N. So it's where the costs are equal to the revenue, and essentially what that is it's commonly called the break-even point. Make sure I spell that out, break-even point. And essentially, it's the idea that as long as we keep going, we're going to start to make money. And I think we can see that graphically, that if we look at this in two sections, so kind of before and after the break-even point, to the left here, I can say that C of N is greater than R of N because the graph is on top of the other. So our costs are bigger than our revenue. We're losing money. But on the other side, I can say that the revenue is greater than the cost. So we're actually starting to make money and, you know, eventually make some profit as well. So for C, it says profit is the difference between revenue and cost. Write a function representing P in terms of N. So to do that, I'm going to say, and it's kind of weird, I'm doing it up here, but the profit, and this is something that's going to be very consistent across any economics course or math course you take in the future, that profit is equal to revenue minus cost. Right, so the money that you bring in minus the money that's going out. And so the profit in this particular case is going to be my revenue function, which is 12n, minus the entire cost function, which is 125 plus 7.5n. Well, that means that profit as a function of n, and here is where we run into a bit of a problem because n is actually being defined two different ways. Right, for C of N, it was the number of t-shirts we made. For R of N, it was the number of t-shirts we sold. And that's why that assumption is so important, that we have to assume that every single t-shirt we make is going to get sold. And I always like to tell students, this is really the best case scenario. So if we did sell only 75%, we know that, you know, maybe this isn't worth it and we should look for, you know, a different money-making adventure. So 12n minus 7.5n, because that negative is going to distribute into the bracket, gives me, so 12 minus 7.5 is 4.5n minus 125. All right, and then the last part wants us to identify the domain of the total cost, revenue, and profit function in the context of this problem. You know, there probably is some upper limit as to how much actual money that we can make. But to really examine that, we also need to see what P of N is going to look like. And P of N, unfortunately, won't quite fit on this, right? P of N is going to start somewhere down here and then, you know, go up at a rate of 4.5 per N. So it's going to look something like this. But what is important is that profit will be hitting the x-axis at our break-even point, because the break-even point is when C of N is equal to R of N. If R of N and C of N have the same value, then the difference between them is 0. So it does make sense that that's going to hit at 0, and that does change our function just a little bit. I'm going to do this kind of a little bit different way. N must be greater than or equal to 0, and it must be an integer. You could put natural number or whole numbers there as well. You can't really make half a t-shirt. It's not really a t-shirt at that point. So I think it's important that we don't jump to that N as an element of the real, because it's really not going to be a real number. Now, for C of N and R of N, there's no upper limits, well, for P of n as well. But what we need to do is identify that where do they start? So if we look at P, let's do P first. P is going to be greater than or equal to negative 125. And we can get away with saying that P is an element of the real, although that's technically not true. P is going to be an element of, the multiples of 4.5, because as n goes up, P is going to go up by 4.5. Perfectly acceptable to use that, though, in this context. For C, it's a little bit different. If we look at our cost function, it costs us, this is total cost right here in blue, it costs us $125 right off the bat. So our cost function is always going to be at least 125. And again, it's an element of the real. For revenue, though, if we don't sell any shirts, we don't make any money. So R has to be greater than or equal to 0, and R is an element to the real. Always weird writing something like that where both variables look the same. You will see in quite a lot of textbooks, they double line the number systems. I've tried doing that, and it just looks like I'm scribbling on the board, so I've kind of given that up a little bit. All right, definitely a bit of a weird section in this course, not quite the same flavor as logarithms or the trig chunk that we've done. It is important that there's nothing wrong with looking this all together. You could certainly use your calculator to plot C of n, R of n, and P of n, and then evaluate these things on your calculator. So the full assignment is up here. Please do make sure you're checking Google Classroom for any modifications that we very likely have made.